Across is a project funded by the European Commission under the Euro-HPC program, with a duration of 3 years and involving the contribution of 8 countries across Europe. The aim of Across is to develop and integrate advanced software components into a full-fledged software stack, supporting the execution of complex workflows mixing numerical simulations, artificial intelligence tasks and big data analytics operations. The Across platform relies on the integration of different components into a multi-layered, multi-level solution. The top level is represented by the platform front-end, which allows the users to submit and stage their workflows, until the scheduler will allocate to them compute resources for the execution. The intermediate level is represented by integration of an advanced resource allocation planner called Warp, a workflow scheduling and execution engine called Streamflow and the Astia toolbox for the management of cloud resources. The effectiveness of the resource allocation policy is guaranteed by coupling Warp with an optimization procedure, which solves a combinatorial optimization problem modeling the resource allocation over the time. The low level of the architecture relies on the integration of the HyperQ component, which allows to exploit the compute resources with a fine granularity, which may be heterogeneous in nature. Thus, the integration of HyperQ allows to maximize the placement of workloads on the allocated compute resources. The Across platform targets the exploitation of heterogeneous compute resources made available through the IT4 Innovations and Sinica HPC centers, as well as the experimental research platform managed by AutoSeven. The heterogeneity of compute resources spans multiple dimensions, including of course the availability of different types of accelerators such as GPUs and FPGAs, the emulation of neuromorphic architectures, and cloud virtual instances. The Across consortium designed the platform in such a way it is modular in nature, making possible to integrate new specialized software components as well as targeting the compute resources coming from new infrastructures. The Across orchestrator is composed of a set of core modules, which are responsible for parsing the staged user workflows, allocating the HPC compute resources and provisioning them with a deterministic process, scheduling the execution of workflows. Other than this, the Fast Machine Learning Engine module, or shortly FMLE, is responsible for managing training phase of machine learning models being part of the user workflows, while the Astia framework allows to manage cloud virtual instances. The Batch Scheduler plugin designed by the Across team provides a fully integrated mechanism, through which HPC compute resources can be reserved in advance, thus providing deterministic execution of the HPC jobs. Efficiency is pursued by exploiting heterogeneous HPC compute elements. On the one hand, this entails exploiting the processing technologies ranging from modern many-core CPUs to a large variety of acceleration engines. On the other hand, by exploiting memory and storage hierarchy, which goes from local caches to burst buffers to global storage system, as well as by mixing programming models. Big step forward is enabled by profiling the system behavior and its power consumption, by optimizing code execution through dedicated libraries, by properly using application parallelization, distribution and task mappings. Last but not least, the adoption of more productive languages along with new resource abstraction models such as containers is an efficiency enabler when used in conjunction with traditional HPC environments and high-performance-oriented programming languages. The Across project aims at unifying analytics, AI and HPC on a single cluster. This implies a change in the compute approach to Converge, which is based on moving from simulations to machine learning workloads and tensors, adopting specific programming models, tools, resource management stacks and file systems, as well as new data formats. Adding analytics and AI on an HPC cluster implies having machine learning models described through high-level frameworks such as Keras and TensorFlow, integrating these models with simulations, and adopting optimization strategies based on multiple resource management stacks. Across project looks at going beyond traditional AI concepts by integrating neuromorphic computing. This is pursued by investigating on modeling spiking neural networks via accurate simulation and emulation processes and striving to assemble a complete ecosystem. The results of this effort are reflected in the AutoSeven and Nova experimental platform that is made available to the project partners. The Auto 7 Innova platform is a hierarchical composition of very diverse compute engines accompanied by their respective software stack, which includes specific programming libraries and analysis and debugging tools, as a low-level hardware interface. This broad range of computing architectures and accelerators includes CPUs, GPUs, FPGAs, visual processing units, dedicated neural network processors as well as the emulation via FPGA of neuromorphic architectures. The whole system is backed by InfiniBand and Ethernet network fabrics as well as by burst buffers and a storage system. One of the distinctive aspects of the Across project is its aim of investigating the use of neuromorphic architectures as a means for accelerating applications. As the project evolves, investigations have been pursued on bringing neuromorphic architectures simulated on FPGAs. Experiments have been performed to progress beyond state-of-the-art solutions by scaling out the number of neuromorphic cores. In the scope of WP2, one of the main activities focuses on so-called simple access and service provisioning of Across platform. The goal of this task is to investigate how Across services could be integrated and accessed by other EU-funded projects and platforms. One of the possible approaches looks at the existing and proven solutions such as Lexis platform and Heap middleware. The combination of the Across software stack and the Lexis platform and Heap middleware make possible to deploy the Across stack on a number of cloud/HPC infrastructures to provide simple access to heterogeneous resources available on site. Specifically, the Heap middleware provides an additional secure access layer and remote access capabilities for computing infrastructures, thus a number of deployed Across platforms could be simply integrated and made remotely available to use by a custom Heap Across plugin. To complement the solution, the utilization of a federated platform such as the Lexis platform would offer the users a centralized place to manage their workflows, computations and data utilizing a wide range of acceleration technologies and software stacks provided by an underlying set of connected Across platforms. The Across project aims at validate the developed full stack through a set of industrial and scientific use cases belonging to 3 different application domains: aeronautics, climate and weather simulations, and energy and carbon reservation simulations. In all use cases, a workflow is defined and tested on the available infrastructural resources, exploiting the full range of hardware and software technologies.